Let's get started. Welcome. Good evening. Welcome to class 6. We're going to talk about avatar optimization today. This is a topic that is near and dear to my heart because VRChat being a content creation platform at the end of the day means that we are all subject to everybody else's decisions all the time. Because unless you want to show nobody and have everybody be their fallback avatars all the time, we're witnessing the culmination of a whole bunch of different people's work all together in one place. And avatar optimization at the end of the day is a very selfless act. It's not for you, not usually. It's typically so that everybody around you has a better experience. Because when you put 80 avatars into a world, if even a couple of people have really made bad choices, and you aren't setting up your shield settings so that you automatically block very poor avies, it can cause problems for everybody, right? So one of my goals of this class is to help teach people how to, what the limitations are, why they matter, some data on the performance impacts of any given thing that we do on our avatars, and then some automatic tooling that we can apply to our avatars without a whole lot of effort in order to make them more optimized, and then some manual tooling as well, how to go in Blender and do all of the fancy stuff to make the most optimized thing you can. I'll speak from my own personal experience here. I made my own avatar from a base. I didn't make it entirely from scratch. I purchased a body, purchased a head, and made the rest of it. I bought a couple of things here and there. Starting off, I had a massive list of different renders here. You can see once we eventually get to this topic, we'll talk about skinned mesh renders, and effectively every single one of these becomes a skinned mesh render unless you combine them under the hood and do a whole bunch of fancy stuff. It was not a very optimized avatar. I think my triangle count is 305,000. Obviously not going to work very well. And I managed to tear this down eventually to a poor avi. I try to target poor or better for anything I wear on a daily basis. Part of that is maximum chance of being seen. That's a little bit egotistical, perhaps, but that's a little bit of ego is okay. If you're a dancer, obviously sometimes it can be nice to have a really fancy avi that has a whole bunch of really nice detailed materials and particles and all that sort of stuff. But also, if I'm wearing a medium or a poor avi, the likelihood that some random person is going to see me is the highest, as opposed to if I'm in a very poor. Same with keeping your texture memory down, right? A lot of people will maximize that, put a cap at 100 megabytes or 200 megabytes of texture memory, and they won't show your avatar anymore. So obviously, in order to both make sure that everybody sees you and as well to be kind to everybody around you, it's good to optimize their avatars. VRChat has, of course, their performance ranking system, as we've talked about in previous classes. It's based upon a bunch of very firm limits, and it's not the be-all, end-all of optimization. We should care about the rest of it too. And in addition, there are things that we should avoid, even though VRChat doesn't penalize us for doing them. So we can pull up the VRChat performance ranking chart here, just to get us started on this topic. I'm going to be going through every one of these in detail today, at least to some degree. So obviously, 7,000 tries, as we have discussed in previous classes, is going to be your limit, and that's going to be one of the bigger ones for a lot of people. We're going to talk about a lot of things, including texture memory, including your skin mesh renders, fizz bones, animators bones, particles, et cetera, et cetera, et cetera. Any questions or comments before we get started, or anything that anybody particularly wants to see covered today? Cool. I'll keep chat open for the voice chat. If anybody has anything they want to interrupt with, feel free to just say something there. In the Unity Blender discussion chat, I put a couple of different links that you guys can go take a look at. The first one is my syllabus for the class today. And then I have a couple of other links in there that we will discuss as we get to them. The first thing I would like to discuss is the obvious. Remove things that you don't need. If you buy an avatar and it has a whole bunch of different items of clothing that you just don't care about, I have 4 different tops on this avi. This sweatshirt, I never use it. I put it on here once just to try it out. I'm not really a huge fan. If I were to buy an avatar and it had 17 different top options, some of them do, and you don't like it, just delete it. Sometimes you're going to have to separate by material, but in this case, I have a whole separate object for it in Blender. So if I were to pull in the FBX, it would be its own separate object, and I can go ahead and say delete. And bam, no more hoodie. There's other things you'd have to do to clean up the toggles and stuff, but already you're saving on tries, you're saving on a material slot, you're saving on an animator layer once you go in and manually make that change. Sometimes these things will already be joined together. So like, let's say that I have like my belly chain, the shibari, and the collar all joined together as one thing, and they were called accessories. So now if I didn't spell that right, whatever. Now if I were to go look at that object, it's just these three separate things. If this happens when you're looking at an avatar and you want to be able to separate them out, you can separate things out by materials in cats. So inside of cats, we can go over to, I can never remember where this thing is. Every time I try to find it, I have to go search. It's in other options, because of course it is. Separate by materials. So we can see it's separate by, it's just my text size. There we go. So if I click on accessories, separate by materials, it actually automatically splits out for us into 4 different objects. The belly chain, the collar, the gem, and the shibari. The gem, I have a separate material just for this gem, so I can apply some fancy refraction effects to it. So if you ever want to be able to go work with an Avi and you open up the FBX and you notice that it doesn't have an object for each one of its things, separate by materials is the very first thing to do. There's other options here. I actually don't know what separate by shapes does. But separate by loose parts effectively does what you'd think it would do. Any object that is not directly connected to anything else will be split out. So for example, on my collar, if I look at just it, this ring here is not connected to the rest of the collar. Same with any of these rings. They're all their own unique objects, and there's no vertex that connects them to the collar itself. So if I were to go in and separate by loose parts on this collar, it would make it into one object for each of these little parts, right? So I have this little front strap here. I have one of the back rings over here, et cetera, et cetera, et cetera. Good to know that it exists. You're typically not going to need to use it. The reason why separate by materials works in the first place is also sometimes even a problem on avatars, because that means that they are using a separate material slot for every single piece of clothing, as opposed to atlasing textures together. That's one thing we're going to be discussing here in a little bit. So removing things we don't need is the obvious first step, right? Take things on the avatar. Like I have 3 separate droppables on this version. I have a yoga mat, the bed, and then the temple logo. On modern versions of my Avi to save on tries, I only have the bed, right? So I don't have the other 2 in there. Especially I think the temple logo has a ton of tries, way more than it should probably. It's almost 70,000 in and of itself. Cool. Let's talk about the automatic steps that we can follow. And I think this is one tool that just everybody should have in their toolkit. Even if you buy an avatar, I think if you just buy an avatar from the store and want to be able to upload it, you should know how to do this thing. And that is using Dark's Avatar Optimizer. So Dark made this tool. It's a really, really nice tool that just automatically optimizes your avatar for you in Unity. So you don't have to touch Blender. You don't have to do anything special. All you have to do is drop this onto your avatar, and it will tell you the things that it's going to do to make it better. Typically, there's nothing else you have to do. You upload it, and it just works, which is pretty crazy, actually. Surprising. So you can add it to VCC here. I'll put a link to Dark's Avatar Optimizer in chat as well, because I think I've forgotten to do that. There we are. Perfect. So I don't think I've added Dark's Avatar Optimizer to this version of my Clara class project. So we'll go ahead and do that real quick. I also did end up adding the 2 plugins I talked about last week for the controller, the animator plugins, and they're actually pretty cool. There's 2 paid plugins that Lindy recommends to work with the animator that are pretty dang nice. I can go over those later if we'd like to. All right, so I have added Dark's Avatar Optimizer. I click back into Unity, and Unity's package manager goes and does its import. This works on just any avatar and typically doesn't come with any problems. Of course, you can just upload it as a separate version from your main one, try it out, see if it works for you. But I think everybody should put this on every avatar they ever upload and only remove it if it doesn't work for some reason. Like if some of your toggles get busted or something. There's no reason not to use it. So we can do that by going over to Tools, Dark, and actually, no, I think it's a component, sorry. Yeah, so on the avatar here, click on it, go to Add Component, and we can type Dark's Avatar Optimizer and add it as a script, and we get this view right here. We're not going to see very many improvements to this avatar because it's very performant, but I can also go ahead and do it from my own, which might give a little bit better results. Oh, yeah. Okay. So that's a much better example. So in Dark's Avatar Optimizer, we're greeted with a whole bunch of different things. The first one is all of the settings that are being applied here. There's a basic, which just does some of the most simple optimizations that typically are never going to cause adverse effects on the avatar. All the way up to full, which might cause more problems for you to try to use it. You're going to get some warnings down here just to tell you what's going on. But I think the real obvious thing here to look at is the actual savings that you get. So this is going to tell you the current version of the avatar and then the version it's going to create for you and all of the different stats on it. So like skinned mesh renders here, for example, we have 9 skinned mesh renders on my version of the Avi. It's going to merge that all the way down to 1. Same with mesh renders from 3 to 1. This would cause issues we can discuss later. Material slots, FX layers, and blend shapes. Blend shapes is a crazy one in particular. Blend shapes have a performance cost even if they aren't being used on the avatar. So like I'll have blend shapes on my body for like, changing the shape of the eyes. Like the head is a whole bunch of blend shapes to be able to go customize the shape of the face and the eyes and the mouth and all that sort of stuff. Typically, we either set that value once and forget it or just leave it at 0 forever. That has a performance impact. It's small, but it does exist. We can instead automatically apply that blend shape so that it no longer needs to be used if we're not animating it, right? If we're not changing those values. Dark's Avatar Optimizer will automatically go find all blend shapes that aren't animated and just go get rid of them. So we can see we go from 340 blend shapes on the Avi down to 22, which is pretty crazy. And this just works. You can just upload this right now and it will function. One thing worth noting on Dark's Avatar Optimizer is that it plays kind of weirdly with VRC Fury. So it won't allow us to create an optimized copy right now here. And the reason why is because we're using VRC Fury and this tool. VRC Fury makes its own weird changes to the avatar before you upload, and then Dark's Avatar Optimizer does it as well. So if we ever want to see what the end result will be with VRC Fury and then Dark's Avatar Optimizer, we have to create a test version in VRC Fury. So under Tools in VRC Fury, there's a Build and Editor Test Copy. What this will do is it'll take your avatar that you currently have selected, go apply all of your VRC Fury toggles onto it, and then give you a version with all of those things applied that you can go ensure that everything works correctly. This automatically happens when you hit play mode as well. That's the thing that it generates. Give it a second to do its thing. Perfect. And we can see we have this test copy down here. This test copy you can already see has a whole bunch of things applied to it. If we were to go look at the animators or the animator and stuff, it would have its own special copy of the animator that VRC Fury created for us. We could even go look at that animator and go see that it created a whole bunch of VRC Fury, a whole bunch of new animator layers for all the various different functionalities that VRC Fury automatically adds for us. So now with this VRC Fury test copy version, now we could go into Dark's Avatar Optimizer and actually apply it. So I think we'd have to re-add that component onto the bottom here. But now that it's applied, we can go ahead and see what it would change it to. Funny enough, VRC Fury kind of already did a lot of our optimization for us, but we can go ahead and create an optimized copy, which will now have both VRC Fury applied and Dark's Avatar Optimizer applied and get the final result. And we can actually go see the number of skinned mesh renders. Ignoring most of these other things in here that aren't actually renderers, we're left with just one, the body. So everything else on the avatar up here, where we can see we have the body, the belly chain, the collar, the hair, the leash, et cetera, has all been merged into just one renderer. And we could just hit play mode here if we want to actually watch this work. It would. I'm not going to, just to save on time. But that's how to use the tool. It is pretty dang simple. You just apply it to the avatar and it just works. One thing worth mentioning as well, in the tools menu up here, if you go to Avatar Optimizer settings, you can turn on this always optimize on upload. Turning this on effectively just means that you can, when you upload the Avi, it will automatically apply itself. So you don't have to hit that create optimized version button. This button over here. You don't have to press this button. It will just do it for you. So that's all the setup you have to do. And then if the full mode doesn't work for you, try basic mode. Like if the full mode breaks something on your avatar, like toggles or shaders or something, try basic mode. And then if basic mode doesn't work, then you can get rid of the script. But I think that every avatar you ever upload should have this script applied to it. Any questions on Dark's Avatar Optimizer? Cool.
Sorry I'm late.
No worries. We'll have the recording if you want to catch up on anything we discussed. But the long and short of it is Dark's Avatar Optimizer is amazing, and you should use it on every upload you ever do. That's it. That's the long rant. It took me 15 minutes. Holy crap. Okay. Moving on.
Wait, it was a quick question, but that will fix anything that could be any kind of problem when you're uploading it?
It's not that it fixes any problem. It's that specifically this is made to attempt to make it much more performant. So it does a lot of automatic merging of meshes and stuff to make things more performant than they would have been otherwise. It has limited effectiveness. A lot of creators, especially a lot of good creators, put a lot of work into optimization of their avatar ahead of time. Flexa comes to mind as a creator that puts in a crap ton of work into making sure that everything is as optimized as it can be. She works with somebody called Door. Door does a lot of like any of the installation menus you've ever seen. If you ever gotten Lyria and looked at uploading her, it automatically has like a bunch of installation menus that just work. And then I've shown in previous classes the grand old blend tree that Lyria has. That's just a gigantic monstrosity of an animator. All of that is done in the name of optimization. And some creators put in a lot of work to make sure that optimization is done ahead of time. So Dark's Avatar Optimizer might not be as necessary. But you should always at least try it. Worst case, it doesn't work and you get rid of it. But it usually just works. So, let's see here. Speaking of pre-optimized blend trees, they can actually make your life wildly more difficult if you're trying to optimize. If you go in and do some manual stuff here, like we're about to talk about, dealing with those gigantic blend trees can actually be a huge pain. I mostly work when I'm doing my own avatar work here on my own avatar that I created from scratch. So I'm comfortable with all the animator layers because like I'm the one who made them. Oftentimes you can just like if you get rid of a piece of clothing or whatever, you can just leave the animations the way they were. It'd be more performant to delete them, but you don't have to worry about it. So now we're going to discuss a lot of the individual. Oh yeah, thank you, Foxy. We're going to discuss a lot of the individual limits when looking at the performance rankings. And we're going to go down the list, basically. I'm going to skip around a little bit, actually. So triangles. We're limited to 70,000 tries if we want to fit within poor or better. When looking at an Abby, we've already discussed briefly about just removing things you don't need. So I removed the sweatshirt. I can remove the temple logo, the mat. I don't know. I don't really wear these leggings. Let's get rid of them. I don't really want to wear these socks. Let's get rid of them. This thigh bulge here is a shape key. You can fix that like that. The thigh high squish right there. And we're already down to 189,000 tries. Only 189,000. We have a lot more work to do. And this is effectively what I had to do when I made my first version of my Avi performant. Right? Get rid of the staff here. I ended up getting rid of the Shibari because it has just a lot of tries on it. Same with the belly chain. I committed atrocities with this belly chain. It's 39,000 tries. Don't do that. Each one of these links is individually modeled, baby. Don't do that. I've learned since then. So I've deleted a whole bunch of stuff, and I'm still at 138,000 tries. That is a lot. And how are we going to go down from there? Well, I don't really want these ears. Let's get rid of those. Still way too high. So there's a couple of things we're going to have to do. Oh, I have this gem here still. Get rid of that. Okay. So tries. I skipped around a little bit in my notes. Oh well. We've removed the unnecessary bits. You can remove hidden things. So let's say that I have this shirt underneath the jacket. Let's say that I'm always going to be wearing this jacket in this Abby. I'm never going to wear anything else. Well, one thing we can do is we can just remove parts of the body underneath the jacket. So if I go to the body, which I have conveniently made safe for work for the most part, we can go ahead and delete parts of the mesh underneath the body. So we go to edit mode and we can just go say like, we'll never need any of this. Go ahead and delete it. I do need a lot of that. And that's a lie, kind of a bunch of stuff here, a bunch of stuff here. You'll never see it. We're always going to be wearing the jacket. Get rid of it. Same with like the shorts, like this whole region is covered by the shorts. We've selected a whole bunch of tries. We can just go delete them. And we put our clothing back on. Well, I messed up a little bit, but for the most part, you can't tell that we deleted anything, at least on the top, right? The jacket covers everything we deleted, and we saved a whole bunch of tries. I think that was like 40,000 or something ridiculous. No, it was a lot. So if you know you're going to be wearing like a safe work model and you can just leave your clothing on, go ahead and delete all the tries underneath it. They don't matter. Decimation. Decimation is a whole topic in and of itself. So, what decimation does is it attempts, the goal of decimation is to reduce the number of vertices, reduce the number of tries on any given mesh. The way that it tries to do that is by looking for places where the angular difference between an edge is the smallest, so that vertex has the least impact on how the mesh looks, and merges it with nearby vertices. And it will do that over and over and over again to try to acquire the desired poly count. So we can go look at just our jacket for this, for example. So I can go ahead and put a wireframe overlay so you can see the jacket. And it has 12,500 tries. So if I were to go apply a decimation modifier to it, we do this over in the modifiers tab, and we go to decimate. This ratio here is effectively the ratio of tries we want to the tries we currently have. So if I were to put 0.5 here, it would try to reduce it down to 6,500 tries from its 12,500. So we can try that at 0.5, and we can watch what it does to the mesh. Firstly, you'll notice it's not all clean rectangles anymore. It is a whole bunch of weird, gnarly shapes. It tried its best to maintain any topology that mattered. So you can see like down here in the armpit where you have a lot of angular difference, it kept a pretty dense geometry down here versus like over on the arms where it's just one big, long, smooth thing. It doesn't have a whole lot of very dense geometry. But this actually poses a problem in and of itself, and is one of the reasons amongst many that decimation is viewed as like a naughty word in a lot of circles. You just don't use decimation.
Right, got it.
One of the reasons why is because of the way it handles joints. Decimation doesn't understand context. It doesn't really understand that our elbows need to flex. It's just looking at the mesh as it is right now. So it doesn't understand that for something that's flexing, you need a lot of dense geometry so that when you extend it or contract it, it looks natural. If you were to try to bend these elbows right now in this version of the jacket, it would look pretty weird. Since it doesn't have that context, it's just applying the reduction in geometry everywhere. It oftentimes leads to some pretty weird results. There is I want to say a vertex group that you can use. I actually forget the option. I should have remembered this before class. Oh well. There is a way to essentially paint with decimate. So you can specify what areas of the mesh do I want to allow it to decimate and which areas do I not want to allow it to decimate using vertex groups. That can be beneficial so that you can stay away from those joints, right? You can say like, I know that this elbow section has to have more geometry, so don't include it in the vertex group, don't decimate it. And obviously too, this can make things look pretty crunchy. So when you go way down in ratio, it still looks mostly recognizable at 1/10 of the tries. That's pretty cool. Here's the original geometry. Here's the decimated geometry. But it can start to look pretty crunchy with more detailed things. For example, hair is a good example. So I actually did decimate my hair on the version that we use. Hair does not suffer from the same issue about joints as we discussed, but it does suffer from, it uses fizz bones. Fizz bones are going to have a similar issue to joints where you want a lot of, if you want a lot of like really nice waviness to your fizz bones, and you don't want them to look jittery, then you're going to want a lot of fairly dense geometry. And in this case, a lot of fairly regular geometry. The way that hair is done is with paths, which leads to this very nice, simple, regular geometry going all the way down it. It starts to look a little bit strange when you decimate it, but I did decimate my hair for my optimized version. So we could go apply a decimate modifier, same deal here, take it down. We can watch what happens when you go too low for hair in particular. I'm going to go really low to exaggerate the point. Yeah, we're at 4% of the original polys, and yeah, you can't use this. That's comical looking. We got some Lara Croft hair going on over here.
So Lara Croft.
Right? One other thing worth noting is how it messes with geometry. This is mostly only useful if you're making your own mesh from scratch here and you want to be able to modify it. But when I'm looking at my mesh here that I made originally, it's very regular. And when that means I can actually select whole loops, I can select edge loops, are what these are called. And being able to modify an edge loop is very beneficial because I can do things like move around these edge loops wherever I want to put them, etc. And even delete or dissolve edge loops wherever I see fit. When you decimate, you lose all of that nice geometry. It's now garbage. Their edge loops don't exist anymore. That's obviously detrimental. One other way of removing topology, actually, let me go double check on my notes. Okay, any questions about decimation before I move on? I should
Yeah,
pause there.
no questions, but just don't use decimation. But like I see you doing when you had it isolated with the certain joints in the last part, that just gives it the more of a fluent move, so it looks natural. Am I correct? Is that what you're saying?
What you're talking about specifically where you apply the decimation, and you're talking about in the hair or in the jacket?
No, when I'm pointing to the thing, but you can't see it. But
Oh,
where
yeah.
you were just showing the elbow, put it on the other view
Yeah.
real quick. Yeah, that. So that's gonna like make it like if you stretch it out or pull it out, that's gonna have a different kind of movement to it, right?
Yeah. If we were to just delete those edges, this is not part of decimation. This is going to be more manual edge reduction, which I actually am about to talk about. We will get right to that.
'Cause all I know is no decimation. Got it.
Well, and even then, don't take away necessarily no decimation. That's not necessarily the point. It's that decimation has a lot of problems, and because of that, it's oftentimes shunned. But I decimated my hair for my optimized version. I took it from this, and I think I went down to like 0.4. The geometry still mostly looks okay, and the fizz bones still look pretty fine, and it has 40% of the geometry that the original hair had. So there are times to use it. Just be careful and use it sparingly. And double check how your joints bend too. Like whenever you test your decimation and get into game, bend like your elbow and see how it looks. Because sometimes it'll look really bad. And you're like, oh, that's why we don't use decimate. Bodies can be that way too. And that's another good point. Following on to decimation is sometimes you can just find lower poly versions of assets. ZinFit in particular has a high poly version and a low poly version. So this is the high poly version of ZinFit, and it shows it is dense. Looking at like the hand here, that's a lot of polys. Oh, there we go. There is
A quick question: the more polys is worse, right? You need it to be less polys.
Exactly. Well, more polys is a worse performance, but looks prettier, right? So it's all a trade-off.
That's why everybody sports very pores because they look badass.
Because they look great, right? Exactly.
And but they're not. Yeah.
Not very performant, and we kind of discussed this at the beginning too. Like performance is not about you; it's about everybody around you, right? Sure, you want your Avi to look badass, but also like don't murder other people's computers unnecessarily, please. Okay. Finding low poly versions of assets. I just talked about that. Like ZinFit has a low poly version you could just import and put on top of the original version. Retopologizing and removing edge loops. This is worth discussing, I think, particularly on my jacket. My jacket is a good example of a place I should have already done this and have not. If I go look at my jacket asset here, we talked about joints and we talked about edge loops. I think we can use that information to surmise how we could make this avatar how we can make this mesh way less dense than polys, which is go remove edge loops in places that don't bend. This whole section right here, like from like here to here to here, I'm selecting every other one to kind of keep some detail. None of this is in an area that bends. We don't really need dense topology. The only thing that the dense topology is giving us here is a little bit more detail on these like folds and stuff. But this isn't even a particularly like bendy area. Like the folds are pretty minimal. So I could go in and just dissolve these edges out. Everything looks basically the same, and we just saved 500 tries. I could, do another 500 on the other side over here. Same thing with this part. And, go find the areas that don't bend, that don't need dense geometry. Go select all their edge loops. To select edge loops, by the way, I'm in edit mode. Go to edge select mode, then holding Alt and Shift and clicking on an edge, and it selects the whole edge loop. Same thing with this like bicep area right here. Select all those edge loops, dissolve edges. Bam, whole bunch more polys saved. We could do that all over the place and save a whole bunch. Now, places like the armpit are a good example where you want to keep a lot of very dense geometry. Armpits, especially when you put your arms over your head, really look bad if you don't have dense geometry in there to make that stretching look natural. There's also another tool that I use called Retopoflow. I talked about it in previous classes and put a link to it in Unity Blender discussion chat. This is a tool that will allow you to take an existing mesh and kind of draw your own new topology on top of it. This can be useful if you grab something that's super unoptimized or like not a game asset, right? So sometimes you can go find like 3D models online of something cool that you want, like say some prop or something like that, but it wasn't made as a game asset, it was made as a render asset. And because of that, it's like it has a lot of very dense geometry or whatever. If it doesn't come with an optimized version and you want it on your VRC avatar, look into this tool. I will avoid discussing it right now, but I do want to do a class sometime in the future on Retopoflow specifically when we use Marvelous Designer, which is another thing I want to do a class on, which is a tool to make clothing.
So these plugins that go into the Blender system itself?
Yeah, so Retopo Flow is a plugin. It's free for student use. I think it costs a lot of money for commercial use. Free for personal use on the GitHub.
Got it.
And then like we talked about Dark's Avatar Optimizer, that's a plugin for Unity, and you can get it in VRC Creator Companion.
Got it.
That's it for tries. Any questions on how to optimize try count? Cool. Doing all the tools we mentioned, you can take an avatar even as bad as the one I originally shared here. I'm going to revert just to show it. There we go. Something as bad as 265,000 tries and get it down to 70K. Basically,
so what are the rules? Like, what are the rules again for the poly counts for the tries of how they're supposed to be in category again?
70,000 is your main target here. So we can go look at the VRChat performance rankings here. This page, I'll put this in Unity Blender discussion.
Gotcha. So good, and that's poor, but they're all 70. But then okay,
and then very poor is anything worse than this poor ranking. So really, what you're looking for is just 70K. If you really want an excellent avatar, shoot for 32K. VRChat's wiki has kind of a funny suggestion. It's like, you never need more than 32,000 tries. I don't know what they were thinking when they put that in there, but I guess, you don't really need any more than 32,000 tries, but we've just gotten very comfortable with avatars with hundreds of thousands of triangles to get some pretty dang nice looking things. But 70K is your target. And it's definitely doable, right? I took my avatar and got it down to 70K by decimating it. Basically all I did is I used a combination of all the different things we talked about. I decimated my hair. I removed a bunch of the pieces of clothing that I didn't want or didn't need. I found a low poly version of the ZenFit base, and I retopologized like my jacket to make it lower poly count. Another comment on having multiple outfits is that like if you have 15 different tops and you only feel like you want 2 of them, another option is to create 2 separate versions of your avatar, one with each outfit. Moving on, I'm going to jump back up to textures. Over in our limits, we can go see that our texture memory is limited up to 40 megabytes if you want excellent, but 150 megabytes if you want poor. And actually, just as of recently, VRC's maximum limitations are now like 500 megabytes uncompressed, and where they won't even allow you to like upload Navi. It will fail safety checks if it's too big. Texture memory is a very dense topic. There's a lot to discuss, but effectively, your main goal here is to each one of your materials on your avatar is going to have images that comprise its textures. You have your color, which is the most basic texture, which is just, the actual color that shows up. But then there are maps for normal maps. There are maps for metallicness and roughness for PBR textures like we discussed last week or 2 weeks ago. I forget. Those maps are huge and play an important part in the total size of your Avi. So if I go look at my Avi, sorry, I got a little lost here. Let's go get unlost. I can go to my textures and go take a look at, say, the jacket. Beautiful. So in here, I have 5 different images. I have the base color, which is kind of what you see primarily. We have our emission map. I'm not using that in this version. The metallic smoothness maps, which contain information for both the metallicness and the roughness, and looks like this. And then our normal maps, which contain information about our normal data, like our zipper in particular, right? Because our zipper isn't modeled, it's just normal. So you can see on the zipper, there's no additional geometry there, but it looks like it's actually 3D at least a little bit, and that's because of normal mapping. Normal maps in particular get surprisingly large. I don't know how big this is in here. 6 megabytes, which is a lot when you're dealing with a 150 megabyte limit for just the jacket. If we look at just these images here, this is just over 10 megabytes. That's a lot for one article of clothing. So there's a lot of different tools we have at our disposal. The first option is how big we make our texture in the first place. We can see that this is a 2K image, a 2048 by 2048. When you're in like Substance Painter, for example, working on creating an asset, you can make this however big you want to. You can go up to 4K. But if you're making a really tiny asset or something that doesn't matter, like say a sword, just to use a hypothetical example, you don't need a 4K texture for a sword. I can hit this button. It will happily generate me like a 30 megabyte file. Don't do that though. There's no need. Actually, I should not have hit that button because now it's going to actually try to make that under the hood. Yikes. Oh, my computer's going to lag here for a couple minutes while it figures that out. Whoopsies. So obviously we can just use smaller textures. Somebody, I forget who it was during a Ferality talk that I was looking at on avatar optimization, recommended considering level of detail on the actual physical size it'll be on your model. And I think they aimed for like a rule of thumb of like 1K texture per 1 meter of size. So like if your body is, 1.5 meters tall, you can use a 2K texture for it. If you're using a jacket that's 1 meter tall or whatever, like a shirt that's 1 meter tall, aim for a 1K texture for it. If you're using shorts that are only a 0.5 meter tall, aim for 500 by 500 texture for it, right? And kind of use variable size textures depending on the size of the object. You don't have to do this necessarily in whatever program you use to create it, or you don't have to resize it in like Photoshop or GIMP or whatever. You can use built-in tools in Unity. So when you select a texture in Unity, off here in the inspector, you'll see a whole bunch of different options. One of the things you'll see is max size right here. This will automatically resize your image for you. And you can actually see the total size that's being applied here of like 0.6 megabytes of the base color, as opposed to the original base color, which is 2.3 megabytes. The reason for the size difference is because this base color, I think, is a 2K image. Is it a 4K image? No, this is 2K. It's compression that does this then. But assuming that this was a 4K image, I can make it like a 1K image now if I want to. And bam, it's suddenly way, way smaller. 168 kilobytes. Tiny. So applying these sizes, and of course, obviously, if you're doing 1K for your base color, you're going to want to do it for everything. So I can go select all of these different things and select 1K texture for all of them. And notice how the jacket doesn't look appreciably different. It looks pretty much the same. And it's a lot less texture memory. We can also talk about compression here and crunch compression. So compression kind of does what you'd expect it to do. It effectively is going to take and apply a compression algorithm to attempt to make things take up a lot less memory than they would otherwise, without actually sacrificing on quality. So compression does have a minor quality impact, but typically it's cost-benefit analysis where you'll have a huge reduction in texture memory and only a minor reduction in quality. If you want to know how compression works, I can talk about it at another time. But effectively, what it's doing is it's assigning like things, like an alias, to combine whole sections or like whole rectangles of geometry or whole polygons, I guess I should say, into one definition and just say, okay, this whole region is black, for example, instead of having to define each individual pixel. Fun topic. Anyway, moving on. Crunch compression. What crunch compression does, and there's an option to use it here or not. Crunch compression effectively reduces the download size of a texture and then just makes it bigger upon it being rendered in VRC. So if you want to reduce the network size of your avatar, but don't really want to worry about texture memory size, you can use crunch compression. Crunch compression does have a downside as well, in that your CPU has to do some work to uncrunch it when it renders the avatar for the first time. So if you've ever gotten some lag when you first render an avatar, in addition to just having to do all the rest of the rendering, crunch compression can actually be a reason why. As usual, I had a ton of content and not enough time for it. So that's classic. UVs. UV mapping is a whole topic in and of itself, but I'm going to discuss it briefly here. Effectively, use good UVing methods when you go to create your stuff. So like we can go look at the UV setups for any one of my particular, I'll use my staff here for an example. UVs are how we translate our 2D image onto our 3D object. And being efficient with your UV mapping means that you're making the most out of your texture. So if this texture has a fixed size of 1024 by 1024 pixels, the denser we can fit our geometry into this image, the more detail we can get for a smaller image. If your geometry is not very well UV'd, and let's say we had like just this somewhere in the corner here, to get the same level of detail, we would have to use a gigantic image. No need to do that. Be smart with your UV. On a similar note, you can also utilize mirrored UVing. So you can, like, if you have parts of your mesh that are the same on the left and the right side, which is very common, right? You can mirror your UVs across them. If I were to look at like my headphones, for example, I have like the left cone here and the right cone over here. We could overlap those. There's tools to do it automatically. I'm just doing it manually to save some time. You could overlap these UVs like this, right? And if you made your texture correctly and actually overlapped them correctly, instead of me just doing it in half a second here, you would get the same texture on both the left and the right side, and you could therefore be more efficient with your UV mapping. If you ever need to add asymmetry onto a mesh that otherwise uses symmetrical UVs, you can actually create a second UV map. So there's support in like Poyomi, for example, for up to 4 different UV maps on an object. So in Blender, we can go down to the data tab, UV maps over here, and hit add new UV map. And we can actually re-UV it over here however we want to. So if I had a symmetrical UV, I could go make it unsymmetrical, whatever, and then have 2 different maps that are imported into, I don't know why it's not swapping here. There we go. 2 different maps that you import into Unity to go do whatever you want with. So if you had symmetrical UVs and you want to apply asymmetrical detail, you could apply a UV map to just the areas you want the symmetrical detail, make it a second UV map, call it like, async UV or non-sim UV. And then in Poyomi, you could use a decal to apply things just to that non-symmetrical portion. In addition, mirrored UVs, there can be some problems with it. Normal maps get flipped. So if you're trying to use normals, that can be a bit of a pain. Use the asymmetrical maps for that. And then Substance Painter. Substance Painter hates overlapping UV maps because of the way it does its like detection of curvature and detection of depth and all of like it has AO and a whole bunch of other stuff. Substance Painter will not work correctly with overlapping UVs. So that can be a problem. There are ways to get around it. Do what you will. That is a lot of information thrown at your face all at once. What else do I have on that topic? One more thing. Normal maps. So there is a concept of, when we do a normal map here, we're applying a lot of very similar looking detail all across this jacket. You can see how this is just the same thing repeated over and over and over and over and over. We don't have to do this. We could isolate just one small section of this image, make sure that it's tileable, and use something called a detail normal map. Detail normal maps will take a very small image, like I could say just this, like say, 50 by 50 pixel section, and repeat it across the mesh by tiling it over and over and over and over again. That is wonderfully performant with texture memory because we don't have to use this gigantic normal map file. If you don't want to apply that same detail map everywhere, you can use masks to make sure that it's only applied in certain areas. So for the jacket, for example, I can make a mask that is just the sections that need this like nylon-ish normal map, and then apply that across everywhere that needs it, which is like everywhere on the jacket but the zipper, effectively. And that's an option in Poyomi. We should go take a look at that briefly. So if we go to Poyomi, I have this jacket 1 I've been using for testing, we can find details. So right here, we can apply this detail texture and a detail mask here, and we have detail normals as well. So detail normal is where you'd apply that tileable normal map. And then you can avoid using a large normal map texture in favor of just doing that. That's all I have on textures. Any questions?
No.
Cool.
I may have one later on.
Yes.
Right now.
There's a lot to unpack with a lot of these topics, and I'm trying to get through a lot of content very quickly. Next up, materials. So whenever we have a material basically for every separate object in our scene because we need to apply textures to each different object in our scene, and each material can effectively only have one texture file. So if we have our jacket, we have our base color for our jacket in our texture. Oh, dear God. There we go. And this image comprises all of the base colors for the jacket. But you can, if you would like, combine materials together using texture atlasing. So let's say instead of just having, I think I actually have a great example of this. I'm going to load this up while we wait. Here. Instead of having just the jacket in an image, what if we instead made an image that had 4 quadrants, and we put the jacket in the bottom left quadrant, and then like the shoes in the top left, and then, I don't know, some other accessory, right? The headphones in the top right, and then say the shorts in the bottom right. That is called texture atlasing. So you can use an image that is 4 times as large to fit the same level of detail. This doesn't sacrifice in detail. You just make a larger image. But what it allows you to do is use one material for all of those different things, and then just point to different sections of the material with your UV mapping to aim at different parts of the image. So I could have a UV map that only targets the bottom left for the jacket, and then a UV map that only targets the top left for the headphones, et cetera, et cetera, et cetera. That allows you to take multiple different materials and combine them all together into just one Poyomi material. That obviously does come with some downsides. Like if you do some special things for any one given material, like I don't think I have any great examples. The gem is a good example. This gem here has a whole bunch of like glitter you can see on it. It's hard for me to get close enough. Oh yeah, I forgot I can scroll down. Has a whole bunch of like glitter and matte capping and a whole bunch of really cool stuff to make it look like a nice shiny gem. I can't really atlas this. If I were to just atlas this with everything else would get these weird matte caps. I'd have to put masks on it. It's a whole bunch of work. So sometimes you do want to have things that are their own materials for a relatively small piece of detail, and that's okay. It's not great, but if you want that detail to stick out a lot, you can. A lot of times too, creators will make a separate material for metallic objects on a mesh because a lot of people like to have their own special like matte capping of metals. And having a separate material for those metals can make it a lot easier for consumers of that object to go do with it what they want. I haven't done a whole lot of cool stuff with my metals on this asset, so it's hard to show an example. The tail is another good example of a place that I'd do a whole bunch of fancy stuff that wouldn't be good to merge materials with other things in the mesh because you wouldn't want all this stuff applied to it. It has like a bunch of matte caps and glitter and all that jazz. There is tools for automatically atlasing textures. So some of your mileage may vary on using them though. There's CATs. CATs can do it with very simple materials. So there's this combine materials buttons. If I recall correctly, this will do atlasing for you, but only of your base color maps and not of all of the other maps on the Avi. In addition, this requires that you have all of your textures correctly loaded up into Blender. Typically, I leave my stuff untextured in Blender and just only bother texturing it in materials in Unity. Lots of weird problems that can happen with this. That's under this optimization atlasing here. And CATS does give you the instruction for PBR and normal maps, which is what we were just discussing, that you can use the Tuxedo Blender plugin. I also have this Tuxedo Blender plugin. Tuxedo claims it can do a lot of like smart decimation tools. I haven't tried to use them. They probably work. If anybody has used them before and has had a good effect with them, feel free to share. But Tuxedo also has atlasing tools somewhere. Somewhere in here there's atlasing tools. I'm not going to bother to go find them. That will automatically take, like I mentioned with those like quadrants of an image, automatically take all of your different base colors and put them into quadrants, or if you want to divide it up into 16 areas or whatever, so that you can atlas your textures together. And I have an example of that over in this project, I think. Let's hope. Maybe I don't. Unfortunate. Sworn I did, but it is what it is. This serves as a good enough practical example of what atlasing could look like. This obviously is not per atlas. This is just one big normal UV file. I shouldn't use the word normal. That's an overloaded term here. But you can kind of see how everything is separated out into different sections. Just apply that same idea, but with many different disparate objects, right? So we have, some part of the object here, some other parts over here. Like these are these little like sleeve ruffle things. And you can kind of just expand this idea out to a larger and larger image to encompass more and more parts of your Avi into one single image, and then just apply a single material to it. That's all I have on materials. Any questions there?
Oh, shit.
We're going a mile a minute.
I'm going to be coming back to you. Don't worry.
Sweet. I encourage it. We're going to have an hour of workshopping after this. I'm going to be going a couple minutes late today. We are at time, so if you need to drop off, I will not be offended. Cool. Moving on. Skinned mesh renderers. So, in Blender, each one of these objects, I discussed this a little bit last week too. Each one of these objects over here on the right will become its own skinned mesh renderer with an armature deformation that we see applied right here to each one of these separate objects. That is a massive performance detriment for each one of these things to be its own object, and they don't need to be. It makes it easy when you are, God, why is it lagging so much? Oh my gosh.
Are you still rendering the thing?
I hope not. Wowzers. Give it a second, I guess. Jeez. I bet you have a Substance Painter here. Get out of here. We don't need you anymore. Hey, look, everything's fine again. Crazy how a Substance Painter, especially with 4K textures, can slow down your piece to do a crawl. So all of these skinned mesh renders can be joined together. It makes it a little bit more difficult to toggle them. You need to use UV discards to toggle these things, but that's fairly easy to do and something we've discussed in previous classes as well. As opposed to just toggling the object. The nice thing about them being separate objects is that you can just toggle the whole thing. So I can toggle like the whole outfit, which I'm not going to do for obvious reasons, by clicking this checkbox over here, and it would turn off the whole outfit all at once. If you have all of your different pieces of clothing, for example, in a single object over here, which is what we're about to do, by merging our skin to mesh renderers. You can't just toggle them on and off. You have to use UV discards within your materials to be able to animate them to show or not show using the cutout rendering preset. So over here, we can see that we have this opaque rendering preset and cutout. You would use UV discards and then this cutout rendering preset to just selectively not show certain tries of the mesh. To merge things together in Blender, it's pretty easy. You can just join all of your meshes together as you see fit. So we've already discussed like removing some of these things that I just don't want on the Avi. I'm just going to go ahead and do that real quick. Ooh, not those. Perfect. So let's say I want to take all of my clothing objects and merge them together. So I have this collar, I have this jacket, I have my headphones, I have the shorts, I have the socks, the shoes, the shibari, the belly chain. Select all of these things. I can join them together by going over to Object and go to Join or hitting Control-J. And now it's just all one object. I'm going to give it a name, clothing. And now this one object encompasses all this stuff on the Avi. They're all using separate materials still, which we can see here in this list. And obviously we can merge materials like we discussed with atlasing. And then we can also just use UV discards to selectively turn on and off each of these individual things as we see fit. But this now, taking it into Blender, will just be one object in Blender instead of being a whole bunch of objects. You can see here, like I have one object for the belly chain, one for the body, one for the collar, one for the hair, et cetera, et cetera, et cetera. That's mostly it on skin mesh renderers. Just merge them together and use UV discards. The process of selecting which things are going to happen in which for UV discards is called UDIM tiles, UDIM tiles. You can also use multiple different UV maps like we discussed in the previous step to control different discards. And then you can also use dissolves or geometric dissolves with UDIM tiles to do some of the fancy stuff that you see on some avatars where clothing like dissolves away as opposed to just turning off.
Right.
I use geometric dissolves all over my Avis because they look pretty. Any questions on skin mesh renders? I'm flying through some of this stuff, but I want to get through it all. Cool. Skin mesh renders, one more thing to note here when we go to a look at our performance rankings. If you want to get excellent, you can only have one, but on poor, you can have up to 16. Basic meshes here. Basic meshes are anything that doesn't need to deform to your armature. So anything that doesn't need to move with your bones. Like, for example, the bed that I have on my Avi. I don't think I have it here, but I have it over here, right? I have this yoga mat, and then I have this bed here, right? These don't have to deform with the actual bones of my avatar, so they don't need to be a skin to mesh renderer. They can just be a basic mesh. And we get an allocation of those as well. We talked about the material slot limits as well. Bones. There's a bone limit of 400 for poor. When you're looking at bones for an avatar, oftentimes like hair and like tails and all that sort of stuff can be a lot of unnecessary bones. I can go show all of the bones on my Avi as an example. There we go, and bones. Oh, I need to make them not octahedral. 6. There we go. So we can see, like, for example, my tail is made up of like 15 bones. You probably don't need 15 separate bones for the tail. It looks really good. It makes the fizz bone all nice and like flowy. But you can go ahead and dissolve bones by clicking on a bone, hitting delete and going to dissolve here or hitting Control X. And that will effectively just remove that bone and connect the two bones, the child of it and the parent of it together. And you could do that along this whole thing here. This does mess with your weight painting. There is probably a way to merge weight painting when dissolving bones. I don't know what it is. If anybody does know, please share. I would love to know. I just manually reweight paint if I ever dissolve bones. Same with hair. Hair, you can also do that same thing to reduce some of the, like, reducing the amount of bones on your hair just makes your fizz bones look less pretty. But you can do it if you have to. There's a lot of times hair will have, hundreds of bones, 162 bones between the head and the hair here. It's a lot of bones. In addition, sometimes if people exported their FBXs incorrectly, there will be leaf bones. Sometimes if you ever see, like if you have on the end of a bone, just like another bone sticking out here that seems like it has no purpose. And oftentimes it will be named like _end in your bone list. That is a leaf bone that somebody accidentally added by exporting incorrectly. When you're exporting, always either use cats and this export option up here, to get the correct operator presets. Or if you're exporting via the file menu, File Export FBX, make sure that you deselect Add Leaf Bones under Armature, this option right here. Make sure that's not checked, because that will add a new bone onto the leaf of every single bone that you have, which will add a whole bunch of unnecessary bones. But if you notice that they're there, easy performance improvement to just delete them. Moving right along, talking about fizz bones, directly related. Lots of limits around fizz bones that are worth being aware of: the number of components, affected transforms, colliders, etc. Fizzbone components. Fizzbone components is just the number of root objects you have that are fizzboned. So like all of my hair is a single fizzbone component, but affected transforms is where you basically multiply basically by your bones, right? So if you have one fizzbone component, but 100 bones underneath it, you have 100 affected transforms. That number can get up there really quickly for hair. Same with colliders. A lot of times people will have it so that like hair collides with your like chest, for example, so that it doesn't clip through your chest. That's really cool. And it looks really good. Like if you've seen, again, I'll go to Flex's avatar, Lyria, has colliders all over the body. So the hair just will never collide and like never clip through the body. Looks great, but definitely has some performance considerations. Reducing the number of colliders you use, and then collision check count. Collision check count is effectively multiplying the number of bones, the number of affected transforms, by the number of colliders. Multiply those two numbers together and you get your collision check count. That can get pretty high up there pretty quickly. If you ever want to discuss fizzbones in more detail I've been learning a lot more about colliders and how to make things look good on that front, so feel free to reach out to me later. And now I'm going to talk about a couple of miscellaneous limits on this page and we can wrap up class for the day. Bound size. Bound size is effectively the total bounding box of your avatar. So the total width, height, and length is enforced to be a maximum if you want it to fit within these constraints. Luckily, you can cheat, which is kind of cool. So for example, I have my temple logo here. This thing is huge on the Avi. If I were to upload this, it would fail bounds checks. I'm not even sure you could upload it, but if you could, it's way bigger than 5 meters. You'd be very poor instantly. But this only accounts for the bounds at the very beginning when you upload the avatar. You can use animators to do whatever you want. So on my avatar, for example, I have this scaled way down and put like inside the body. This is how I upload the temple logo on my Avi. And then I have an animator that just moves it in front of me, scales it up. And that's how you can get around the bound size limitations. I don't even know really why they include this, to be honest with you. It doesn't hurt performance, not really. Avatar Dynamics contacts. This is common with a lot of props that you'll get from creators. So anything that has, if you've ever seen like guns or fancy, like a lot of Lindy's assets, everybody's familiar with Lindy, have a ton of different contacts involved with them. There are limits on those. Same with constraints. Constraints are also often used for props. Just understand how that these limits exist. And, props, if they're made by a good creator, will have all of their the number of contacts, the number of constraints listed on the prop before you buy it. We've talked about bones. You can basically ignore the number of animators. Lights. Having even one light on your Avi puts it at poor. Having any more than one light on your Avi makes it very poor. Most people don't use lights for lights. I'll leave it at that. So you're probably going to have a separate version of your Avi that's very poor for those sorts of activities. You can't get around it since you can only have one light.
The whom or the glow around you, that counts too?
No, lights. So lights in the traditional sense are typically used are like an actual like spotlight, for example, on an avatar. Like if you've ever seen an avatar with an actual like flashlight, that's a light component. But lights are also used for a lot of special effects on avatars. If you've ever seen like the Hollow shader that uses it, or any of the like SPS systems, all of those systems use lights under the hood, and pretty much you can't have an optimized Avi. It will be very poor. So you have to have a separate version if you want to use those tools. Particles. Keeping it brief on particles. Just to do what's worth covering here. Total particles active is worth covering. This is a limit effectively saying how many particles can you have active at any one given time. But it doesn't actually know. Particle systems are weird, right? They basically emit X number of particles per second. So on every particle system, there's a max particles that can be active. You set that number. Total particles active is just adding together that number for all of your different particle systems on your Avi. So if I go look at, for example, I have like my foot trails. Those are trail renders. That's not useful. mesh particles. There we go. So I have a particle system on my body here. It emits 800 particles per second, and they live for 1 second. So I set my max particles here to 800, which is to say I can only have 800 particles in the space at any one given time, which makes sense because I'm just multiplying my rate over time by my lifetime. And that's the maximum number I'll have anyway. But this number is important because the VRChat system under the hood adds up your max particles for all of your particle systems. That's how it gets to this total particles active number. Particle trails and particle collisions can both be very, very cool. You can have them enabled on medium and poor AVIs. You can't have them on good or excellent AVIs, but particle trails in particularly do a lot of really cool effects for dancers. And you can do that and still be optimized. Pretty cool. Same with trail renderers, right? Trail renderers, I have them on my feet. So as I move my feet around, you can see the trail of where they were moving. You can have up to 8 of them on poor AVIs. I'm not going to cover cloth. Pretty much it's just universally recommended not to use Unity cloth components, but you technically can. You can have up to 1 of them and up to 200 vertices on that cloth if you choose to do so. Same with audio sources. If you want a cool effect on it, cool, but don't, you know the problems that come along with that. And then physics colliders and physics rigid bodies. These are used for spring joints. They're used for if you have throwable objects that collide with the ground, all that sort of stuff. You can have a couple of them on your AVI and still be within medium or poor. Any questions on any of the miscellaneous limits or anything that I have been word salading at you for the past hour and 15 minutes?
Oh my God, dude.
There's a lot to cover.
It's a lot, dude.
Yep.
Oh my God. That's all right. I'm ready. I just got a new laptop. I'm ready.
Let's go. Awesome. I love getting people into this. None of this should be too daunting. I mean, these are all, at the end of the day, VRChat allows us to upload very poor AVIs, but it's really good to be optimized. One other note I have in here, my gigantic list of notes, this is what I've been referring to all session, by the way, is quest limits. A huge oof is my comment there. Wow. I was tired when I wrote this. 10 megabytes total download size is the major quest limit. So Quest has its own performance limitations. So we can see them down here on mobile, the mobile limits on this page. And they are way more restrictive than the PC limits are. You can have only up to 20,000 tries to keep it poor or better. That is pretty abysmal. But the only thing that Quest systems actually require from you is that the download size is less than 10 megabytes. That's mostly going to be down to your texture memory. It's actually interesting that it allows for texture memory greater than that. Compression is the only way you can do that. But that's the only limit you have to stick within. Otherwise, you can just have a very poor Quest version. It's fine. It works. But to wrap up, I'll go refer to my notes again just to emphasize how much I mean about this. Please optimize your AVIs. Optimization isn't for you. It's a selfless and generous act. We want to be kind to everybody around us in the instances. We want everybody to be having a good time regardless of how good their computer is or isn't. And the way we do that is by being cognizant of these limits all the time. On that note, sometimes premature optimization can have a cost. If you're trying to get into AVI creation, I know I fell into this trap. Just like if you're ever trying to do design work and artwork together, oftentimes it can help to have a vision. So have a vision for what you're trying to create, design it, sketch it, whatever you're going to do, come up with all of your ideas ahead of time, then go make the thing. Make it fully, and then go optimize the thing. Spend intentional time up front on your design to save time down the road. It's easier said than done, but it's a skill to be learned amongst the many other skills to be learned that we've discussed today. And that's all I have. Any other questions before we wrap up for the day?
No, I'm going to hit you up in the instant message because I want to know certain particulars.
Sure.
I might need it down.
Absolutely. I welcome it. And I'm going to be here for the next 45 minutes or so doing a workshop. I got a ping. Let's see here in open chat. Perfect. Thank you, Swan. I really appreciate it. And thank you, KitPup. Cool. Well, that's all I have. Thank you for joining. Let me know what topics you want for next week if you have any particular things you'd like to discuss. Otherwise, I'm probably going to be doing something on UV mapping or maybe asset creation. I had an idea to make like a slot machine, which would be fun for some of the animator work we discussed last week. And we get to use parameter drivers, which would be kind of cool, which is the whole reason to make a slot machine in the first place, is to show off that you can do logic in a Navi, which is kind of cool, like actual randomness. But yeah, I might make a poll on that topic, just on what we want to discuss next week. But if you have any ideas, feel free to hit me up. Otherwise, thank you all for joining, and I will see you soon.